Hello everyone. In this lecture, I am going to talk about digitization. In the previous video, we have discussed about what is georeferencing and how to perform georeferencing in ArcGIS environment. Before going into today's lecture, let's recap a little bit. Georeferencing is a process of assigning a spatial referencing system for data. Normally scanned images doesn't contain any coordinate reference system associated with them, and performing georeferencing makes them to be inconsistent with the data what we are using in GIS. So after georeferencing, here in this lecture I'm going to discuss about what is digitization and what are vector datasets, and also how to perform digitization in ArcGIS. Coming to what is digitization. In general context, digitization is the process of converting information into digital format. In GIS context, digitization is performed to convert a paper map, that is analog map, given into a digital format, and digitization results in a map which is editable by nature. Digitization normally results in vector datasets which later can be converted into any format which the user desires. And there are many types of digitization, that is heads-up digitization, heads-down digitization, automatic digitization, and so on. In today's experiment, we are going to perform heads-up digitization in ArcGIS environment looking at the computer monitor. So if you are interested in learning what are other types of digitization, that is heads down and automatic digitization, so I'll be preparing a few more videos soon. As I said, digitization results in vector type of datasets. Let's focus on what are vector datasets. In GIS, data can be represented normally using two different types of data models, that is vector and raster data model. Raster data model represents data in the form of regular array of grids, which we call them as pixels, and these raster images are more suitable for representing continuous type of data such as temperature, elevation, because the temperature and elevation values will change in a smooth fashion and at a continuous level, whereas vector data models are best suitable for representing discrete features, and vector data is represented using points, lines, and polygon. For example, using vector data model, you can represent where a tree is located, where a ground well is located. These type of objects are normally discrete by their nature. More about vector and raster details I'll be preparing in coming videos. Now moving on to digitization in ArcGIS, there are certain prerequisites which you have to complete before performing digitization in ArcGIS. First thing is, we require a base map from which we are going to prepare a digitized map. The base map can be any scanned image or aerial photograph or any other image. And next prerequisite is georeferencing. We have to perform georeferencing before we start digitization. Incorrect georeferencing or no georeferencing leads to producing a map which is incorrect in spatial dimension. That is, if you are preparing map of India or if you are preparing map of any state or district or village, there is no guarantee that the map will be spatially correct in the sense it will stay at its correct coordinates. Another thing is, you need editor toolbar to perform georeferencing. If you are not seeing editor toolbar in your GIS, you can add it via customize menu. So now let's see how to perform digitization in ArcGIS. I will open ArcGIS. So I am going to create a blank map first of all. Then here you can see editor toolbar is already added in my ArcGIS interface. If it is not added, you can display it using the options present in customize menu. Go to customize, then toolbars. Here you can see editor toolbar is already activated. If it is not activated, you can simply select it so that the editor toolbar will be activated and displayed on your ArcGIS interface. Next thing is I'm going to do some basic settings. So go to data frame properties, then change the display units into decimal degrees and map units also into decimal degrees. Then assign the coordinate reference system as WGS 1984. Here, though I am assigning 1984 coordinate reference system, depending on your location, you can choose your coordinate reference system for the map whatever you are preparing. Once you are done with assigning this coordinate reference system and altering the display units and map units, next step is adding the base map. So here I am going to add the base map of Hyderabad. If you remember, we have already geo-referenced this particular image in the previous video. You can have a look at the previous video in case if you don't know about how to perform geo-referencing. Next, to perform digitization, we require to create a shape file where our all digitized data will get stored. And I also mentioned the digitization results in vector datasets, and vector datasets are basically of point, line and polygon types. So if you want to store data, depending on what type of features you are trying to store, whether you are going to store district boundaries which are polygons by nature, or you are going to store road features which are lines by nature, or you are going to store simply locations of different areas like Kukatpalli High Tech City which are visible in this map, you may go with point features. Right now I am going to create such features depending on what I am going to digitize. First of all, I want to digitize this Hyderabad outer boundary, so I am going to create a polygon type of vector data set. Here in ArcGIS environment, these vector data sets are nothing but shape files. Now I am going to create a folder on my desktop. For creating a new folder on desktop, I'm going to select the desktop which is visible under folder connections, then new folder, and I'm going to name it as Digitization. Next, right click Digitization, then say new shape file. As I said, we are going to create shape files which are nothing but vector data sets. Here you can see it is asking to specify the name. As I said, first I am going to create the boundary of Hyderabad area, so I am going to name it as boundary. Then it is asking for feature type. Since boundary is of polygon type, I am going to select polygon. Then you are going to specify the coordinate reference system. Earlier we have specified WGS 1984, so we are going to specify the same coordinate reference system, that is WGS 1984. Then say OK. Now you can see that boundary shapefile has been created and is visible in your table of contents. Now your job is to create some data in this boundary shapefile. So let's go to editor and say start editing. So after that, in editor toolbar, if you look, there are so many icons. You have to go to the last icon, that is create features. Click that one and select boundary. Then in construction tools, you have to select the polygon. So after that, simply you have to mark the points using the cursor either in clockwise direction or in anti-clockwise direction along the boundary. For doing better digitization, it is best to zoom the map and then mark carefully the points along the boundary. Here, since I am explaining how to perform digitization, I am not going to zoom it. So after marking the points, when you are coming to the last point, simply double click, so the polygon will be closed. So this way you can digitize the polygons present in your base map. You can draw as many polygons as you want in a single shapefile. I am going to draw only one polygon. In case if you are interested in marking one more polygon, you can simply draw another polygon like this and simply double click at the last point. But I am not interested in drawing this additional polygon. So what I'm going to do is I'm going to select this polygon and then I'm going to delete it. So once you are done with marking all the polygons, save your edits, then say stop editing. This is how you will digitize polygon type of features or boundary features present in your map. Then your next step is to digitize roads. You can see that roads are not visible now. To see the roads that are present in your base map, you can simply uncheck the boundary shapefile present in your table of contents. Now you can see all the roads. Now for digitizing the roads, you need to create one more shapefile. Digitization, new shapefile, and shapefile name is roads. Feature type is polyline, since we are going to digitize the roads. Then coordinate reference system is WGS 1984. Say OK. Then again come to editor, say start editing, create features, roads, and construction tool which you are going to use is line tool. Then start digitizing all the roads like this. Simply mark the points along each and every road so that you can complete the digitization of a road. So I'm not exactly moving along the road, but you can carefully and slowly move along all the points in the road for proper digitization. So like this you can digitize each and every road that is present in your base map. Once you are done with the digitization of all roads, save your edits, then stop editing. You can see all the roads there. If you want to change the appearance of these roads, you can simply click the line shape present under your roads in table of contents and then change the shape like this. Next. So this is what we have created just now. And if you are interested in marking the locations of different areas present in Hyderabad, again you have to go for digitization, new shapefile, and say area or say locations, and feature type is going to be point. Coordinate reference system is WGS 1984. Then say OK. After that, go to editor, start editing, and you are going to store the data in location file. So select location, then select point, then mark the points wherever you want to mark the locations of different areas like Kukatpalli, Amirpet, or some other location like this. So this way you can digitize all the locations, and once you are done with digitization of all locations, simply go to your editor toolbar, save your all edits, and then say stop editing. So this is how you will be performing digitization in ArcGIS. If you have any queries, please drop your comments. Thank you for watching this video.